In this video, I will demonstrate how to display data in SPSS using box plots and bar charts, including error bars. Now, typically we use this sort of technique, this graphical technique, to represent data in a way that is maybe a little bit more explanatory than we might get from just reporting the means and the 95% confidence intervals or standard deviations. So we can present a graphical picture of how groups of data, especially when we talk about groups of data, are represented relative to one another. So if you have groups of data in which you wish to represent the means, and especially when you wish to compare means of multiple groups to one another, then using these types of graphs can be a very instructive way to present that kind of data. Now, the first technique involves what's known as a box plot, or also known as a box whisker diagram, and it can be a really useful way to display your data. And what this is going to indicate for you, and we'll get a good example of this when we actually do the demonstration, it's going to represent in the box the median score for your data. It's also going to represent the interquartile range, and then the score that represents the top 25% of all the scores, and the score that represents the bottom 25% of all the scores. So let's go ahead and do a demonstration, and then I'll be able to explain how we interpret this a little bit more specifically. So we go to, or what we have here is we have data from three groups that had three different instructional techniques, and then they all took an exam in order to see if either of the three instructional techniques could produce a greater or lesser exam score, a better or worse exam score. So we have three groups, and you can do this with 2 groups, 3 groups, 4 groups, 5 groups, and we have one numeric outcome score. So we want to go to the Graph menu and click on Chart Builder. And so the first technique we're going to look at is the box plot. So down here on the bottom, under the Gallery tab, we can choose some different techniques. And we're going to go ahead and click on Box Plot. And we're going to do a simple box plot. So we want to highlight that and then click and drag it into the upper box. Okay, the next thing we need to do is then label our X and Y axis. So our X axis is going to be our grouping variable, so the different teaching techniques that were administered, and you'll see that pops up as a label there. And then our Y axis is our outcome, our numeric outcome, in this case test score. We want to move it over into that particular box, or that particular area there. So once we're finished with that, we can click OK. And one thing I should point out before we do that is over on the right hand side, you can see this thick bar here in the center of each of the box plots. As I mentioned before, that represents the median score for the data, and that's the default. You can change that to represent the mean or the mode, for example, but since traditionally box plots represent the median score as the center or as the most prominent characteristic, we're going to leave that as box plot. And we're going to click OK. And so on our output then, we will see our 3 groups identified on the x-axis. And then what we see here is the thick black line in the center represents the median score for each group. So we can see the median score for the first group here is equivalent to, it appears to be around 30 or 35. The median score for this group is somewhere around 70 or so, and the median score for this group is down near 20, maybe 25. Okay, so that's the most obvious feature. Now the next thing we can look at is the actual shaded portion of the box. Now this represents the middle 50% of all scores, or the interquartile range. So the 75th percentile is represented here, the 25th percentile is represented here, and so the shaded portion represents the middle 50% of all the scores. Now as we look at the whiskers, so from this portion to this portion, that represents approximately the top 25% of all the scores. So the top 25% of all the scores range between this score and this score. And then the bottom 25% is represented down here. Now I say approximately. In this case, it represents exactly the bottom and top 25%. But if we have a situation where we have an outlier or an extreme score, then you will see that represented by a small dot or an asterisk outside of the box plot. So any score that's greater than the upper quartile plus 1.5 times the interquartile range is deemed an outlier. And so you would see that represented by a small dot there. And any case that's greater than the upper quartile plus 3 times the interquartile range is labeled as an extreme case. So when that happens, when you have those individual scores outside of that, these whiskers no longer represent exactly the upper or lower 25%, depending on how many outliers or extreme cases you might have. And so we can have outliers or extreme cases at the upper end as well as at the lower end. So in terms of this, we can see that there are definitely some differences as far as the median score between each of the groups. And it appears that we have no outliers or no extreme scores in any of the 3 groups. We can also see that the lecture group had a much wider range of scores compared to the independent studying group, for example. And then the collaborative learning group had kind of the tightest range of scores, or had the smallest range of scores, but we can definitely see some differences among these 3 groups. So that's how we can use box plots to represent groups of scores. Now the next demonstration I want to do is how we can represent independent means, 3 independent groups and their means, using simple bar charts. Okay, so we're going to work with the same data, and now we're going to not move from using box plots to bar charts. And again, this is a very common technique for representing group means. It's probably one of the most common ways to represent that. So in order to create these bar charts, we want to go back to the graphs and click on Chart Builder. And now we want to choose bar graph or bar, and this will give us several options as far as different kinds of bar graphs we want to do. Now since we have 3 independent groups here, we are going to use a simple bar chart. So let me reset so you can see how this would be done. So we want to choose simple bar, and again we want to click and drag that into the preview window. And then we need to identify our X and Y axis, just like we did with the box plots. So technique is still going to be my X axis, and score is going to be my Y axis. Now we can go over to the element properties area, and again we can change the statistic that's being represented by the top of the box plot. The bar chart. So we're going to stick with the mean. You could change it to the median or the mode, but we're going to use the mean. And then we can also display error bars. Now we have options. We can display the standard deviation, we could display the standard error, or we could display the confidence interval. And the confidence interval is probably the most common way we would display error in this situation. So I want to make sure that confidence interval is checked. Now I've got several styles I can choose. We've chosen the most common, the bar style, but there is an I-beam and a whisker style that gives a very different look to the bar chart. So you can play around with that and see what you think looks the best or looks the most appropriate for what you're trying to do. So we're going to stick with the traditional bar style. And then we go ahead and click Apply. Okay, you can now see the error bars represented, 95% confidence intervals. So once we've completed our designations here, we go ahead and click OK, and this will now be displayed in our output. So again, what we're seeing here is the top of the bar is representing the mean of each of the 3 groups, and then these whiskers here represent the 95% confidence intervals. So again, we can see definite differences in the means, and in some cases we can see some overlap in the 95% confidence intervals, certainly between the independent group and the lecture group, and we can also see some separation in the 95% confidence intervals between groups as well. In this case, the collaborative learning group and the lecture group and the independent studying group. Okay, so the next technique we want to learn is a variation of the bar chart. So I'm going to close this, and let's go back to our graph menu, Chart Builder. Let's go ahead and reset, this, and we're going to go back to the bar chart option, but we're going to use a different option, and this is the simple bar error, or error bar technique. And so what this allows us to do is kind of unclutter the graph a little bit. Before we had these large bar graphs, and that can be kind of a lot to look at. And so this kind of simplifies that and uses a dot to represent the mean of each group, and then the whiskers represent the 95% confidence interval. So it's a little bit cleaner, and it allows us a little bit of an easier way to kind of compare the relative positions of means and certainly the 95% confidence intervals to see if those confidence intervals may overlap, and that can be a little more clear in this technique. So we identify the axes the same way we did before. So the x-axis is still technique, and the y-axis is score. And again, we can have the circle represent whatever we want, but the typical would be to have the mean represented by the circle. And again, we can display error bars as well, and in this case we're going to display the 95% confidence intervals. And so we can go ahead and click apply, and then click OK, and then we have this represented in this particular output. So you can see it's a lot cleaner, a lot less cluttered. So this represents the mean, the circle represents the mean, and the whiskers represent our 95% confidence intervals. And I think it's a little more clear now. You can definitely see that there's a lack of overlap in the 95% confidence intervals compared to the middle group and the right-hand group, and there's definitely an overlap comparing the left-hand to the right-hand group. So that's just another variation of ways that we can use bar charts to represent independent means. Now, if you have a situation in which you might have two independent variables that you wish to compare means upon, so in this, taking our previous example a step further, we've got our three different teaching techniques that we want to compare the mean test score on, but then we also want to compare by group and also by gender to see if there's a gender difference within the groups as well. And so in this case, we'd use something called a clustered bar chart for these independent means. So again, these three groups are independent of one another, but we want to be able to kind of separate out the group means by teaching technique, but also by gender. So in order to do that, we go back to our graphing menu and click Chart Builder. And so we're going to, again, select bar chart, but now we're going to select clustered bar, and we're going to drag that up into our preview box. Now the next thing we need to do is continue to identify our x and y axis, but we also need to identify how we want to cluster the bars relative to one another. So we're going to keep technique as our x-axis label, and score continues to be our y-axis variable. And in this case, we want to cluster the bars based upon gender. So I want to move this into this little box in the corner that's labeled cluster on x-axis. So once we have our x and y variables labeled, then here's our clustering variable. In this case, it's going to be gender. We can then, again, look at what statistic we want to use for the top of the bar. In this case, we're going to stick with the mean. And again, we also want to display error bars, so we're going to click that and choose confidence intervals, and then click apply. And then once we have all that entered, we can click OK. And we can see in our output then, so we move down here, we've got our three groups designated by gender. So the mean score for lecture, again, separated out by gender. We can see the blue represents male and the green represents female. We can see the same thing for collaborative learning and also for independent study. Now, in some cases, and you can see this little warning signal here, it says one or more error bar calculations yield infinite results. And so what that means is the 95% confidence intervals calculated for this subgroup of lecture was so large that it won't show up on the chart. So it could actually end up being kind of a negative or a large negative 95% confidence interval. So when you have that situation, which is unusual, you won't see an error bar show up. But again, this is how we can represent independent groups that we then separate out by another categorical or another independent variable. So it allows us to kind of break that down even further. And again, conclusions we could make here is obviously the means for these three groups, we can see they're a little bit different now. The males who had lecture had a much lower score than the females. And we can see, again, the males in the middle group also had quite a bit of lower score than the females in the middle group. So that's another way to kind of separate out different effects depending on different levels of variables that we might have. Now, the next example we can cover has to do with showing simple bar charts for related means. In other words, means that are related in the case of maybe a repeated measures ANOVA or a dependent or paired samples t-test, in which we have the same people being measured multiple times. How can we produce bar charts in those situations? So in this case, what I have is blood pressure measurements on 22 people measured pre-test, partway through a blood pressure treatment, and then at the conclusion of that blood pressure treatment. And so we've got 22 people that have been getting all the same treatment and have been measured 3 times on the same outcome. So in order to present a bar chart for that kind of data, we have a little bit of a different technique or a different set of directions that we need to follow. So one thing you'll notice with this data is we no longer have a grouping variable. In other words, we no longer have an independent variable that we can use to designate groups. So that's going to change slightly how we approach this technique. So we're going to go back to graphs, back to chart builder, and we're going to highlight bar, and we're going to choose the simple bar graph, and you can just double click on that and that will move it into the preview box as well. So what we're going to need to do in order to designate the y-axis is we're going to have to move our 3 outcome measurements over into the y-axis together. So we need to highlight, hold down the control button, and then click all 3 variables so they're all highlighted simultaneously. And then we drag that over into the y-axis. So now once you've dragged your variables over into the y-axis, you'll see that this new dialog box has popped up. And this box is telling us that SPSS is creating 2 temporary variables. One is called summary, which is going to be our outcome variable, in this case blood pressure, and the other is called index, which is going to represent our independent variable, in this case what we manipulated or the type of intervention that we used. So SPSS uses these temporary names because it doesn't really know what our particular variables represent, but we are going to change them to something that's a little more descriptive. So just click on OK to get rid of this dialog box for now. So the next thing we need to do is edit some of the properties of the graph. So you can see some of the options that we have. And if you don't see that option, go ahead and click on element properties to produce that little window that we need to see. Okay, so first thing we want to do is select display error bars, and we're going to do that with the 95% confidence intervals. Okay, so the next thing we need to do is edit that x-axis to be a little bit more descriptive. So we want to click on, in the edit properties box, click on x-axis. And then yes, we want to make changes, so click on yes. And then in the box labeled axis label, we want to go ahead and type in something. So we can call this whatever we want, but I'm going to call it intervention. You can call it treatment, whatever you like. And then that's going to label the x-axis for us. That's something that might be a little more descriptive. Maybe it's drug intervention, maybe it's exercise intervention, whatever it might be. You can call it whatever you would like. And then we go ahead and click apply. Now at this point we can also change the order of our variables, in this case our measurement points. So if you want them in a particular order, you can change them. In this case, there's a time dependency here, a pre-test, mid-test, and then a post-test. So we're going to leave them in this order, but you can use these little arrow buttons to the side to move those around in whatever particular order you would like. Okay, and then if you make any changes, you need to click apply again, so those changes become applied. Now we can also do the same thing for the the y-axis. Right now it's labeled mean, we can change that. We could change that to mean systolic blood pressure, for example, so that that's a little bit more descriptive. And then I can go ahead and click apply. And again, that can be whatever you want it to be as far as how you want to label your outcome and how it's represented. Now you can also use this box to set the scale so that you can have kind of a different scale as far as what the y-axis represents. SPSS can do that for you automatically, or you can set it so you have specific increments between points on the scale so that you can kind of change the dimensions of the bars relative to one another as well as to the total scale. So that is something you can also do in this particular box. All right, once we've done that, we can go ahead and click OK. We can click OK and then look in our output here. And again, we can see the top of the bar is representing the mean for each group, and the whiskers are representing the 95% confidence intervals. So we can see a definite change over time as far as the mean for the group, and then we can also see the 95% confidence intervals as they are arranged around the mean. Now the last example of a bar chart that we can talk about are clustered bar charts for what are known as mixed designs or split plot ANOVAs, in which you have a grouping variable, and so you want to study the effect of a treatment, a between subjects effect, and you also have a repeated measures element, the within subjects effect. So this is sometimes referred to as a factorial repeated measures ANOVA, and this allows us to look at the effect of group and also time, and then also the interaction between those two. So we can do bar charts, in this case a clustered bar charts for those kinds of mixed designs. So the data we have here is again related to teaching style, and so we had subjects take a pre-test on statistics knowledge, and they took a post-test on statistic knowledge, and they were subjected to one of two different teaching techniques, and we wanted to see if the group had an effect, the teaching technique had an effect, as well as just the passage of time, if that had an effect. So if we want to graph that interaction and certainly that effect from each of our two variables, we can use a clustered bar chart. And so we're going to set this up similar to how we set up simple bar charts for repeated measures or for related samples. So we want to go to the graphing menu, choose Chart Builder. Okay, and we want to choose a clustered bar chart. Okay, and then our y-axis is again going to be our two measurements. Okay, in this case, knowledge level is part of a pre-test and is part of a post-test. So we want to highlight our pre-test and post-test scores, okay, and drag those over to the y-axis. Okay, and again, we're going to do this in a few minutes, so we can go ahead and click OK. All right, then our next thing we need to do is indicate how we want to cluster these bars and group. In other words, our different teaching technique is how we want to cluster them. So we want to drag group over into the cluster box. And then the next thing we can do is change the index, change that x-axis label. So click on x-axis, and we can indicate a new axis label. So in this case, we're concerned about the passage of time. We're doing a pre-test, post-test, so our x-axis label could be time or whatever you want to call it. Okay, so we can go ahead and click that, and we've got that taken care of. The next thing we want to do is display our error bars. So we want to make sure we click that and make sure we're showing confidence intervals, and click apply. And I believe we have everything we need. So again, we want to make sure we're moving our repeated measures over into the y-axis, and then we want to make sure we're clustering the bars based upon our independent variable, and then we want to make sure we're labeling what's happening over the passage of time, what the x-axis is. In this case, it is passage of time. So once we've done that, we can go ahead and click OK. And then in our output, we can see our repeated measures, our pre-test scores broken down by type of instruction, and then our post-test scores broken down by type of instruction as well. And so that is how we can do a clustered bar chart when we have repeated measures as well as we want to cluster by another independent variable. So hopefully you found this video instructive, and good luck using this technique in your own research.